Okay, remember that t to the kv is the space of covariant tensors from the k-fold Cartesian product of the vector space V with itself. And what we want to do now is construct a basis for this space. And we have the following proposition. The set of tensors epsilon I1 tensor and so on, tensor epsilon to the ik, where every I is greater or equal than 1 and smaller or equal to n. This set forms a basis of t to the kv, and this is what we are going to show. Of course, to show that this is a basis, we need to show two things. First, we need to show that every tensor in t to the kv can be expressed as a linear combination of elements of B. And second, we have to show that the elements of B are linearly independent. So let's take an arbitrary tensor, let's call it T, which is an element of t to the kv. And let's define numbers t I1 to ik by setting this number to t applied to ei1, comma, and so on, eik. So this number ti1 to ik is the result of applying the tensor t to this tuple of basis vectors ei1 to eik. And now let's look at the following linear combination: ti1 to tik. This is this number we have just defined, times the tensor epsilon ik, tensor, and so on, ik, applied to ej, comma, and so on, ejk. Yeah, we can evaluate this. This gives ti1 to ik, epsilon I1 applied to ej1. Remember, epsilon I1 is just the dual of the standard basis vector ei1. So this gives a bunch of Kronecker functions, and our result is ti1 to tik, Kronecker I1, j1, and so on, times Kronecker ik, jk. And this evaluates to tj1 to tjk, because everything else is 0. But this is just t applied to j1 applied to ej1 to ejk by definition of the number t. So we have shown that t applied to this tuple of basis vectors can be expressed as this linear combination of elements of B. And by linearity, we have also shown that in general T can be expressed as a linear combination of elements of B. So we are left with the task to show that the elements of B are linearly independent. So let's assume we have a tensor, let's call it T1. that is the zero tensor, and it is a linear combination of elements of B. So there's T I1 to IK, epsilon I, and tensor, and so epsilon IK. Remember, we are using the summation convention as usual. And this is 0. But we have just seen that this evaluates to Tji to Jk if we apply it to Ej to Ejk, and this has to be 0 because T1 is the zero tensor. So this number Tji to Jk has to be 0, and this is for all J1 to Jk. So we see that it follows from the assumption that the tensor T1 is 0 and is a linear combination of elements of B that that every T J1 to Jk has to be 0. So the elements of B are linearly independent, and we are finished with the proof. Thanks for watching. See you next time.